to software engineering. We will be covering the rest of patterns today. Some behavioral patterns, basically. Where the heck did my thing go? Okay, here we go. Yeah, so it looks like we need to do UML, Decorator, Singleton. We covered Singleton already. And UML, I know you've had that in other courses, so I'm not planning on covering that in full. I'm also waiting for Chapter 7 to download. So basically, Chapter 7 is from the Zooey book. So I'm going to be covering that today, and hopefully that'll be downloaded by the time that I'm done with, it says 3 minutes long, so hopefully it'll be done with the time I'm done with Decorator and UML. And then we'll cover that. So got a few things to cover today. This will probably be a good 20 minutes at least to get through all this stuff, maybe later. I try to keep my YouTube videos purposely short because I realize that it gets kind of dry watching all this stuff. So I try to keep it shorter than a typical lecture. Just get through it. So here's some slides for unified modeling language. This is important to cover, I think, from the perspective of it is standard software engineering content. And hold on a second. So basically we've got use case diagrams is one usage of UML. Alright, so as I was saying, UML basically is a way of modeling various things. This is doing use case diagrams. And if you see here, we've got another option, which is to use it for class diagrams and object diagrams. We can also use it for sequence diagrams, scenarios, state chart diagrams. So there's a lot of different things we can use it for. This is what it looks like in a class diagram format. Where we've basically got the class name, attributes, operations, etc. This is showing, like, for example, the observer, which we talked about last time, with the subject observing, and the observer, or the subject calling an update on all observers, basically. I'm recommending that for your object diagrams that you use something called DIA. It's a free program that you can grab. I think there's actually other locations of DIA other than the one shown there. I usually just go to Google and type in DIA UML, something like that. Like if you go to here, DIA UML, maybe something like that. Yeah, you get it right away. Editor for UML, static structure. Oh wait, what is this thing? Is this it? I think this is it, yeah. Let's double check. If we type in dia UML, my internet connection is really crappy here in Seattle. But I actually had to transfer over to my hotspot connection because the hotels was, I think people are starting to wake up over here. It's 740. But it's one of these anyway, dia sheet UML or dia structure your diagrams. Hopefully this finishes downloading soon. So I'm going to cancel that actually, but that's what you got to do to grab it. So this renders, this is a way of doing your actor diagrams, your use cases, and your relationships. This is a simple user diagram for what the user can do, sort of in use case format. And these are relationship diagrams for what the user is enabled to do through the software. Sequence diagrams are more about the communication between objects at an object level. So like class roles, lifelines. This one, for example, is the observer sequence diagram. So here we've got, this is related to the last talk I gave, where basically we see that the update is called by the concrete subject. It calls update on concrete observers A and B. So it's going to, for all observers, it's going to call notify, and then update is going to be called on the observers as well. Here's one for a drawing program. So when the user selects graphics, it goes to an event handler, that goes to draw, that goes to the window manager. So basic sequence diagram there. What is going on here? 1.8 of 1.9. Geez. Let me just do a quick search. Do you guys use Everything? This is a cool program. Everything. Much better search system than what's given in Windows. Windows can't seem to get its search right no matter what it does. So I always recommend Everything. Looks like we're not fully downloaded yet, and I'm gonna try to 1 second. Let's see, a few seconds remaining. So alright, that should be ready to go soon. Now the next topic here is decorator pattern. This is also known as a wrapper. Basically what the decorator pattern does is, let's say we have an object already and we just want to add properties to it. This is a great pattern to use if you've got GUI components and say you want to add things to them like scroll bars, or you've got, I don't know, a document that you want to add headers and footers to. In terms of game engines, we think about, well, entities that we want to add things to, like equipment or something like that. So we can add responsibilities to these objects without affecting the objects themselves. We're essentially, it's like basically you're saying, well, look, we don't want to fully extend the class because these are just individual components that can be added to the thing itself. So suppose, for example, we have a text view GUI. We can add different types of borders, plain, 3D, fancy, different types of scroll bars. Now, if we were to use fully inheritance-based solution, we have to account for all the different permutations of those things. So that's 15 different classes. For example, text view plain, text view fancy, text view 3D, text view horizontal, text view vertical, text view horizontal vertical, text view plain horizontal, plain vertical, plain horizontal, etc. So it's an explosion of classes, and the Gang of Four, the Gamma folks that wrote that book, sort of figured out that yes, this is an explosion. We should do something about it. So they came up with the decorator pattern, where basically what you will have is This is kind of close to real, but it's not fully real. This is similar to what they do with JComponent. Basically, we'll have a border that has three possible decorations on it, plain, 3D, and fancy. A scroll bar that has two possible decorations on it. And the decorator itself contains possible components such as border and scroll bar. So JComponents then can have one or more borders, and they will be essentially decorated by those borders. This is what Java, for example, does for its beveled border. It does a set border. And then notice in here, this is the key. Notice it's calling new beveled border. That is an object that's passed into set border. So it's decorating it with that. Now here this is decorating it again with a scroll pane. So this enclosing object is called the decorator. The decorator conforms to the interface components, and we see that therefore that's how the pattern is implemented. Another example is here. We've got a buffered reader decoding the input stream reader. So there's a few more examples. I'll put these online so you can download them. I've also included it in the week 6 content. Another good example is the file input stream. In this case, we decorate it with object input stream. So this allows you to read objects that are implementing serializable. And you can see all that in week 6 content.zip. So, on to the next topic here. Here we've got design architecture. So this is one chapter where I'm going to actually break it up, and we'll be talking about this next week as well. If you look at the, well, hold on a second here. Look, I think I'm going to have, there we go. We do have to look next week at the composite pattern and composition in general, but we'll be covering some of week 7 next week as well. So, the thing about this content for chapter 7 is that it's really about detailed design. We want to think about common architectural styles, techniques that we use in the detailed design, and then we also have a section here where we're going to talk about user interface a little bit. So design should start from the requirements and taking a look at how that software is going to be structured to, this is software design essentially. This is structuring things in terms of components that fulfill the requirements of the high-level design. And we've got a look here at the architecture, which is sort of guiding the detailed design. This is where, for example, like one of my sort of my side job here is with Boeing, and we've got an architecture which is MVVM, for example. Well, since we made the MVVM, which is model view model architecture, that influences the detailed design that we make. So everything we do has to fit that architecture. And that's why you see architecture kind of transposed down upon the detailed design, the requirements coming in. Now requirements might, that's why you've got a little gray or a big gray arrow here going to architecture. Requirements do influence the architecture, but not in a direct way. All requirements should be satisfied by the detailed design, and you should in fact be doing a trace through of all of those. But the architecture is what tells you how you're going to fulfill those requirements in the detailed design. So kind of run out of time here. I think I want to cover a few more slides. This is the structure of the solution for software architecture. We've got the major software elements, externally visible properties, relationships among these elements. Every software system has some type of architecture, whether it's been purposefully architected or it just sort of organically comes about. Now, most of the code we've written so far as undergrads here is small enough that it sort of comes organically. But now that we're doing larger projects, it's going to be important that you consider the architecture of the software you're doing. So I'm going to want you to come up with architecture for your projects, such as I mentioned before, like if you're using WPF or MVVM or whatever it is you're using. And then one way of thinking about this is the views and viewpoints. So the view would be the representation of the system structure. Crutchin suggested 4+1 views, where we've got the logical, the process, the subsystem, the physical architecture, and then the use cases. So the logical is like the decomposition of the object-oriented structure. The runtime, sort of the sequence diagrams, the subsystems that are composed of it, the physical architecture itself, so what it's running on, as well as the use cases. So next, what we're going to do is we're going to talk about different architectural styles and patterns. And I think this is where I'm going to stop the recording for today, and we'll pick up from here next week on this slide. And we'll talk about things like the pipe and filter design, client-server architecture, model view controller architecture, and I'll probably be showing some examples of all of those as well. So since we're in GoToMeeting here, I'm going to kind of pause and wait for any questions. Otherwise, we're good to go. Alright, so it looks like you guys are all straight. So let me again remind you where we're going from here. We're at week 6, and so this was the first of the architecture videos, and we'll continue this on week 7. I do have a homework up here. Let me talk about that a little bit. This is in this meeting. That'll help. Yeah, so this is filling out the software requirements in Appendix B of XUI. Let's see. This is a sample SRS I put up here because I realized that some of this stuff we haven't gone over in great detail, so I wanted you to have a sample to work from. This was done a couple years ago in this class. It's sort of taking a long time to load, but you get the idea. You can take a look at this. Yeah, I don't know, I've got a really slow, poor connection here, but there we go. So this is now there's a definition section, general description of the product, assumptions and dependencies, interface requirements, functional requirements, classes and objects. So this is where your object diagrams can come in, perhaps. Non-functional requirements, logical database requirements, sequence diagrams, data flow diagrams, state transition diagrams, So this was a decent SRS, and now I've got this. I'll talk a little bit more in class about this. Let me see what due date I put on here. March 9th. Okay, so that's going to work. We've got class again together on the 6th. That should give you 3 days there. Well, 4 days pretty much to get it turned in, and we'll talk a little bit more about that SRS on Monday. All right, see you soon.